have that it is now 12 o'clock, so I'm going to get started as people keep rolling in. What you can expect for today is we are going to be talking with the lovely Kristin McMurry, who I will introduce in just a second, and we will be talking about approaches to decarbonization. I want to give you a heads up that this is a two-parter. There will be a wonderful cliffhanger at the end. There's so much great content that we have to get through that we needed to break it up into 2 sessions. So Kristin will be rejoining us in August for that session. And really the way that we are breaking it down today is we are going to talk about decarbonization technologies that still enable steam today. And the next session we'll be talking about hot water and the possibilities that creates for us. So with that, I will shut up and I will introduce our wonderful guest for today. Kristin, would you mind saying a few words about yourself?
My name is Kristin McMurry. I've been at RMF for 9 years now, in the master planning department the entire time. In the last several years, we've been doing a lot of decarbonization work. So that's been my focus for the last maybe 5 years or so. It's been decarb specifically.
You have a lot of great things to share with us today. I'm super excited for that. Could you, for the folks that might not know much about the master planning team at RMF, could you share how many people are on the team and what does a master plan deliverable look like? What is the thing that you developed as a team?
There are 5 of us, so a very small team. And a master plan is a plan that looks at a campus in the long term. And we're looking at the campus as a whole. We're not looking at one specific building or just a handful of buildings. We're looking at the entire campus and how they can plan for the future. And by long term, I mean 25 plus years. So actions that they can take today that can make an impact over a long period of time. And we're looking at what kind of actions can they do that will reduce their emissions for the foreseeable future.
That's super interesting. I think that holistic view is there's so much that goes into it, and we're going to touch on some of those things today. So thanks for that preview for folks that might not have a big handle on master planning yet. I'm going to share my screen here. So today what we are going to cover is some of those decarb approaches. And as I alluded to earlier, if you were just jumping on the call, today we're going to be talking about approaches that still enable steam infrastructure. So because we had to draw a line of how to break this down, there's so much to cover. So for today, we're going to talk steam, and next session in August, Kristin will be back with us to talk about hot water and the technologies that enables. So I'm really excited for that. So from there, I want to talk a little bit about the general overview of an approach to decarbonization. And this is just sort of a way to bring us from the last session of what is decarbonization over to what Kristin is going to share with us. This is an overall approach to a client comes to us, they say they want to decarbonize, here's where we tend to do the order of operations. So first off, what we tend to do is energy efficiency. So that's going to be a shout out to all my buildings people out there. The very first thing that you want to do is reduce the demand that we are going to have to decarbonize later. And so just as a preview, we will be talking about that more in future sessions. I know for a fact that we will be covering passive dorm, for example. So we'll be talking about a really great way to reduce the amount of energy that needs to be consumed at a building. So that's a really great place for our clients to start, whether they're a college or a university, is let's be as efficient as possible in the building. From there, we go to the actual generation side. So we have that demand side, but then we go to generation of how do we produce the energy needed to power these spaces that is a decarbonized system. From there, we can introduce renewables like carbon-free electricity to help meet that demand. And that's a part of the master planning process, is how does that fit in the portfolio? And then finally, are there other ways for us to get down to that net zero that include carbon offsets or sequestration, or even carbon capture is something that we're going to talk about today because Kristin was awesome and included that. So with that, I am going to share another slide and ask you, Kristin, tell me where you start when you are approaching a master plan.
So one of the first things we do when we get a new campus that we're going to start doing a master plan for is we start to look at the meter data and the utility bills. We want to make sure that the meter data lines up with the utility bills. And we're going to check for the validity of the data, both by looking at those bills and also by looking at how does the weather correspond with the data. So we want to see that the heating loads increase as the dry bulb temperature decreases, and likewise for the cooling load that it increases as the wet bulb temperature increases. Electric loads might be fairly steady throughout the year, or they might increase in the summer or increase in the winter, depending on whether they have electric heating or cooling.
Very cool. And so tell me a little bit about this idea of seasonality. I think that that's a really interesting point. We're talking about an overall load.
Well, one of the things we're going to do is we look at this profile, and we're really not looking at the heating and cooling as separate systems. We look at them together. And how do those heating and cooling loads balance each other? Do you have cooling throughout the year, or is it only in the summer? And likewise, do you have heating loads throughout the year? Do you have substantial summer heating? If you have winter cooling and summer heating, it opens up some doors, which we'll get into a little bit more when we talk about the low temperature hot water technologies. With steam, it's a little bit less of a factor, but it is something that we always do look for, and it's the technologies that we recommend will be based upon that.
Exciting preview for next time. Hold off on that for hot water, how roughly we can repurpose that chiller load to heat. So that's exciting. All right, so next up, can you tell me a little bit about how do we, so you're involved in thinking through the most efficient options possible for generation. How do you measure that efficiency?
We use a term called the coefficient of performance, which is defined as the thermal energy out over the fuel or electrical energy in. And I know that that sounds very similar to efficiency, but it is a little bit different because we're not just looking at combustion where maybe we are just creating heat and you put in either natural gas or electrical power and you're going to create heat from that. But what we might do instead is we might move heat from the cooling side to the heating side. And in that case, then we have thermal energy that we've moved from the cooling side, say 1,000 units, and then we have 1,000 units that we've moved over to the heating side, but it only took 800 units of energy to do it. So now we have a COP that is greater than 1, which, as engineers know, you can't have an efficiency that's greater than 1. So this is a little bit of a different term, and it's one of the most important things that if you take away nothing else from this, take away COP. It's very important. And the higher your COP, the better your efficiency.
Absolutely. And so that ratio, as it were, ends up as a number that we assign to a specific piece of technology. And we'll say something like that has a COP of 1 if it uses as much energy, or if it puts out as much energy as it uses. So there's this helpful diagram that you helped create that really helps visualize that. Can you walk us through this?
Yeah, so the orange dots or the green dots are the fuel that we're going to put in, and by fuel I might mean electrical power. And then our red dots are the heat that we produce or the heat that we're moving. So something like a natural gas boiler, which has an efficiency of 80%, you have a COP of 0.8. Electric boiler, 100% efficiency or maybe 99% efficiency, gets a COP of 1. But then when you get into the technologies where you're moving heat from one system to another, that's where you get into these COPs that are greater than 1. And that's going to be the ones we talk about next time with the low temperature hot water.
Absolutely. So yeah, we've helped develop which ones are going to still be enabled for steam and which ones are more of a hot water kind of technology. So can you help us understand, for this 0.8 of a natural gas boiler, what makes it less efficient than an electric of that 1.0? What knocks it down? Where does that energy get lost?
There's just heat losses within the boiler. The boiler just can only do so much. I know that's kind of vague, but
no, that's really helpful to just know that there are losses through that transfer. So that's where that comes from, and that's why we knock it down from the 1. Great. Cool. All right. So next up, let's dive into these technologies. There is a lot here. I want to acknowledge that for everyone, that there's a lot to get through today. But could you walk us through some of these technologies that are going to apply to steam as we've referenced?
Yeah, so on the previous slide, we only showed two options for steam, but there's actually a lot more than that you can do. We only showed the boilers, but you can change your fuel. You can use biofuels or hydrogen. You could use a nuclear reactor. That would be an SMR or a small modular reactor. You could do the straightforward option and do the electric boiler, or you can do combined heat and power. I know we do a lot of those systems. And depending on what the electric grid is like, that might actually save carbon. Or one of the newer options would be industrial heat pumps, and those are becoming more and more available and getting more developed as of now.
And that one was new to me, so I'm really excited to talk about that today. One thing that I noticed in your introduction is that you were saying, and this was something that Martha talked about in the last session, that there's usually a mix of technologies that comes into play when you're talking through what a portfolio is going to look like for a client for those next 20, 25 years. How do you know which mix is going to be beneficial for a specific client?
It's very case by case. You have to look at all the different factors that they would consider to be important. You have to look at what their weather is like. What are their load profiles like? We showed one earlier that was a heating dominant campus. There are doors that are open to a cooling dominant campus that are not open to a heating dominant campus. So an air source heat pump will work a lot better in a warmer climate than it will in a very cold place. Here we're looking at North Carolina on the left and then New York on the right. So I'm looking at the one on the left, if they already have hot water installed, then I can look at doing a lot of simultaneous heating and cooling where they're going to move heat from the cooling side over to the heating side. And then they get a really great COP. It can be as high as 7, which is pretty exciting. But on the other hand, the much cooler climate doesn't really have those same options. And in this case, they don't have those simultaneous heating and cooling loads. Mm-hmm. So we're going to look at a lot of factors, but a lot of it is going to be what is the climate like and what is the profile like?
Exactly. And, even bringing back what we talked about last time, what are the regulations like? What kind of demand do they need to meet? What kind of carbon reduction do they need to meet? There's got to be a lot of different factors you're weighing in. So let's look at another one.
So then we also look at what do they have going on right now? Did they just install new boilers and they're going to be very upset with you if you tell them to replace them immediately? Because if that's the case, then you probably find a way to work around that. Do their distribution pipes, do they need to all be replaced? Because then maybe they're in a good place for an overhaul. And maybe it's a great time to transition to a new technology, maybe from a steam to low temperature hot water system. What do the buildings have installed? Do they operate at 140 degrees or do they operate at 180 degrees? Does the steam come in and hit a heat exchanger? There's all kinds of questions that come up there, and we need to figure out all of those because we don't want to recommend something that is not feasible for them. If it requires them to overhaul every single building on campus, they're not likely to do that.
Right. That makes a total sense. So at any rate, I think that one example that is really interesting is to think about too, like the campus plans that are out there of like, what is the expansion that they are looking to do? What are opportunities? I can think of Carleton College, which is a case study that we'll get to in a couple of months here, but they knew that they were going to be renovating their science center and they put their geo plant in the basement of that. So leveraging those opportunities can be really smart as we're thinking through that master plan. All right, let's look at the next one here.
So then we also need to look at what options are really available to them financially. Some campuses have a lot of money and they're willing to put a lot of money towards decarbonization. Some of them simply don't have the funds or are not willing to put it towards decarbonization. Sometimes the people who hold the purse strings are not interested. That's something we need to look at. We also need to look at what are the costs of their utilities, the natural gas costs compared with the electricity. Do they also have any planned construction that maybe we can piggyback onto funding for that? Because sometimes if they don't have a lot of funding available, there might be ways around that. because maybe if they're already planning to dig up a field, maybe that's a good opportunity to install some piping.
Absolutely, absolutely. I know of one client that is working on a rule about every time you're digging up or replacing something on an athletics field, you got to consider if there's a bore field going to be there, for example. So, yeah, really great point.
Example.
And then, of course, I will recall back to our last presentation where IRA can be a really exciting funding opportunity. Donors, there's a lot of ways that our clients finance this work and try to be intentional about it. And sorry, I'm using an acronym. The Inflation Reduction Act is a tax incentive program we talked about last time. Great. So let's talk about risks.
So this is going to be one of the biggest things. Early on, when you meet with a client, we're pretty much at the kickoff meeting almost. You need to find out how willing are they to take some risks. Do they want to be at the cutting edge with technologies and maybe use that as an opportunity for an educational program? Or they just want to be able to put that into their brochures and use that to get in new students? Or are they worried about making sure that they use tested technology that has been used for decades and they're really, really confident that it's going to work? We also have to look at the staffing. How much staffing do they have? Can they handle doing a more complicated system? If they're looking to stay on steam, are they having a hard time staffing steam? Because sometimes it's harder to find steam operators for boilers. And so sometimes that can be a driver. And then do they have access to things like, they might have an appetite for new technology, but if they don't have access to it, if let's say they want to use hydrogen fuel, but there is no way for it to get distributed to them, then it's not a realistic option for them.
Absolutely. I think one phrase that I hear the master planning team use frequently is leading edge versus bleeding edge. And what side does the client want to be? Can you describe that differentiation for the group?
Yeah. So sometimes when you have a new technology, you maybe hit the jackpot and then you're leading edge and you get to show it off to all your students and, all the investors and everything else. And that's great. But if you use a technology that's not tested, and it doesn't work well, or something falls through, I use the example of hydrogen. Let's say they put in a hydrogen boiler, but then they can't get the actual hydrogen fuel. Now they've spent a lot of money on that and they kind of have some egg on their face.
Yeah.
Or worse, maybe they can't even provide heat to their system. And that would be, we would never, ever recommend something like that to happen.
Yeah.
But that's something we do have to consider. And you don't want to be so ahead of technology that you end up just bleeding money. So we call that the bleeding edge.
And I think that RMF's philosophy is much more that leading side. We are less willing to recommend a really risky option to a client. And I would say unless they're really pushing for it. So maybe their values is that they want to be innovative and they want to be the first one. Okay. But I think the master planning team is really great about recommending what is not necessarily tried and true because these things are so new, but the fact that they are going to work and we want to do our homework and make sure that these things are operable. So
yes, we are a conservative group. We make sure that things will always work.
Yes, and I appreciate that. And I think the clients appreciate that. So all this to say is that this all sounds like a major balancing act. And what I like to offer here is a diagram that shows what Martha likes to call the three-legged stool. Is we are always balancing for our generation. What is the cost to do it? What is the energy that we are getting out of it? And then what is the carbon that we are actually reducing as a part of this? So with that in mind, can we look a little bit at some ways that you are comparing the energy options as a next step?
Yeah. So this is, all the different colors are showing the different ways that energy is being used on a campus. So the green is the buildings. You can see it stays steady. It doesn't change when you change your technologies for heating and cooling. But when you get into the others, there's the blue is the cooling, and that's pretty much always going to be electric. And then the red and natural gas and the orange is electric, and those are both for heating. And that's really where your big variances are going to show up. So these in the first half on the left-hand side, that's mostly natural gas options. And then we also have the electric steam boiler, which does have a reduction in energy use. Then you get into low temperature options and it gets even lower. You can kind of see it sort of step down as you go towards water source heat pumps.
Yeah, and that correlates to that efficiency, that COP that we're talking about. So we can
Yes,
really
exactly.
see that difference that it makes. And one thing I really like about this graphic, thank you for doing it this way, is stacking. You know, there's still energy happening, even if we're electrifying or something like that, that there's still energy being used. So, you know, what are the impacts there? I love that.
And generally usually, if you reduce your energy, you're going to also reduce carbon, but it's not really a one-to-one. So if you go to the next slide, these are the same technologies. But you'll see I mentioned that the electric steam boiler had the lowest energy use of all the steam options, but it is not the lowest carbon emissions. So you have to look at that as well. And what's most important to them is probably what it might be the fuel, because that affects their annual cost, but it might be the carbon. So you have to look at that three-legged stool and what's the most important thing to them.
Yeah, biomass really stands out to me here of like, ooh, how much are we really helping in terms of our carbon change when we are still producing a lot of those scope 1 emissions? And as a reminder to the group, we went over scope 1 and 2 emissions and 3 in our last conversation. So if that is unfamiliar to you, please go back and watch. But as a brief overview, scope 1 is going to be things that are combusted on site, and scope 2 is going to be more things combusted by the utility to get that energy. Am I saying that accurately, Kristin?
Yeah, or like a really simple way to think of it is like scope 2 is the things that you purchase.
Yeah, that's great.
So well, you purchase natural gas, but then you burn it on site. But you purchase electricity, and that goes as scope 2. Generally speaking, scope 2 is going to be the electric.
Right. And so now that you're bringing that up, let's talk about electric, because one really great question that I got from Juan when we have a Zoom group or a Zoom chat group, if anybody's interested in joining that. And one thing that Juan pointed out after the last session is he hears from colleagues, well, what's the point of electrifying if the grid isn't green yet? So can we talk about that a little bit?
Well, it's really because we are expecting it to get greener. And as I mentioned at the very beginning, master planning is always concerned with long-term planning. So we are not looking at what's going to happen in the next 5 years, but rather what's going to happen in 25 years plus. And there's a lot of legislation saying that they're going to reduce the greenhouse grid emissions. And so this is showing like the light green is what's mandated by the government for this particular location. And then the dark green is what we're saying as a very conservative estimate, what it maybe could be. And then the reality is probably something in between there.
Right, right. Yeah, I think it's important. Oh, and thanks, Juan. Shout out to Juan. But it's a really important topic, and there's a lot of change being driven by regulations, et cetera, for utilities to green their grids, but the actuality of how much are they going to get it, I really like this graph showing this is what we're actually expecting during that time.
Yeah, and this is exactly the thing that drove why I said the electric boiler might not be the best option for carbon in the previous example, because in their example, their grid was pretty dirty. And so they were, like pretty far to the left-hand side of this graph. But as they move towards the right-hand side, then, every few years or so, they should probably reevaluate and see whether it's time to uninstall the CHP and look towards another technology.
That's a really good point that, it's not necessarily the grid overall that you're looking at, but you are looking specific to the location as well. You are thinking place-based of this is how green this utility that actually feeds this campus is. So that's really awesome. Right?
Yes.
All right. Well, let's talk a little bit more about if you are going to decarbonize your electricity source, what some approaches can be for that.
Yeah, so as you saw when we looked at the scope 1 and scope 2 emissions, even after doing a bunch of decarbonization technologies, there's still going to be some carbon left over, and you have to figure out how you're going to deal with that. you have really two categories of options. You have on-site renewables, which are things right on your campus, like solar PV panels, or like a CHP plant, if that's more advantageous for you. But you might not have space for it, or there might not be a desire to change maybe a field that's beautiful and they don't want to put on a bunch of wind turbines.
Yeah.
So in that case, then they can move to off-site renewables, which are things like agreements to buy green power. So that would be like a PPA or RECs. And that's basically they put money towards a utility company producing green fuel sources.
Great. Yeah. Awesome. Cool. Thanks for that. And then let's talk about another fun one that is news to me. So thank you for bringing this to my attention. But let's talk about carbon capture. So if there's carbon happening, could we take it out?
Yes, you can. So basically what this does is it will capture the carbon that is coming right out of the stack. And you can't really tell necessarily in here how big this is, but it has a very, very large footprint. And it's a pretty exciting thing, but it is primarily used by utility companies because of how large this equipment is. You're not really going to be able to just hide this on a campus and go, look how beautiful it is, unless you like looking at this kind of thing, which a lot of us do. But in master planning, we deal with a lot of architects who won't like that kind of thing. But it's important to note there's additional energy that's required to operate these. You need a location to store the carbon that you've sequestered, which you might have difficulty finding. And again, it's very big. It's really used primarily by like utility companies and manufacturing plants. So really, really big users. And as a result, it might not be appropriate for most of our clients.
Yeah. Yeah. Very large scale. I love that concept that it's manufacturing or utility, something like that, where it can be an option. And from what I understand, the biggest question is, where do we store that carbon out after we take it out of the atmosphere? That can be a real challenge for these systems, but super cool to know that they exist. And for us to be able to share that vocab, if somebody, a client on a client end throws it out there, like, what do you think of it? This is an appropriate response. Or to say, hey, I've got this great colleague, Kristin, that can tell you bit more about that. So cool. So I would say next up, let's really dive into some of these decarb technologies, the ones that still enable steam. And I want to say thanks to Tracy for the question, because she was saying, with biomass having so much carbon emissions, like what's even the benefit of it? So what we'll do is we'll look at some in more depth at some of these technologies and those pros and cons. And as we look at pros and cons, I do want to give a heads up to people that the number of pros and number of cons doesn't mean that because there's 3 pros and 6 cons that this is the one that we should never use, because some of the cons are real deal breakers. So just pay attention to what Kristin has to say for pretty major pros and cons for these technologies. So why don't we start with biofuels, since that one is hot on people's minds.
So there's several different types of biofuels. You can kind of read what the different types are here. I won't read them out loud to you or anything. But in answer to that question, when you burn biofuels, they do still emit carbon, but it is carbon that would have been emitted if you left it sitting there and didn't burn it. And so the difference is how quickly does it get emitted? And that's kind of a bit of an accounting question as far as like, how do you count that carbon? Mm-hmm. And different clients look at it in different ways. So that's kind of the short answer to that. So there's biogenic emissions, which are the ones that come out anyway. And then there's non-biogenic emissions, which are much, much smaller.
Yeah.
And that's why a lot of times we're able to say that biofuels are green technology.
Yeah. So with our oils, we have ethanol, biogas, repurposing that cow methane, that sort of thing. Renewable natural gas, though, would you mind describing that to our listeners?
Yeah, so renewable natural gas is kind of like buying a REC. You are purchasing regular natural gas. What will go into your boiler is normal, plain, regular natural gas. So you don't need to make any changes to your boiler. But what you're paying for is for the utility company to invest in green sources for them to get the natural gas. So there's it's kind of balancing itself out so you can kind of come to a net neutral.
Yeah, that's great, because I think previously I had thought it was some other kind of natural gas that was created in a renewable way, but it's really helpful to know how that works. All right, could we go over some of the pros and cons of these different biofuels? You had alluded to a few already, but we're going to break this down between solid biofuels and gas biofuels.
And so for solid biofuels, the only thing you really need to change is the boiler equipment. You need to put in something that can handle solid fuels. That's obviously going to be different than a natural gas boiler. But otherwise, you can leave everything else as is. So your distribution and your buildings can stay exactly as they are, which is going to be the case for all steam options. It's by far the biggest driver for why steam is oftentimes a really great idea to keep on a campus.
Yeah. For those that might not know, distribution for steam, we're doing district energy for a lot of our clients. So that would mean there's pipes going throughout your entire campus distributing that steam. Those pipes have to shift to a different size if we're doing hot water. So that means you'd have to replace all of that piping, which is a major infrastructure project. Just wanted to give people a heads up on that. And we'll talk more about that next session, but that's why it's so expensive.
Yes, and it's also disruptive to the campus. There's a lot of times a big drive to not do that.
Yep.
But back to biofuels, they do have a lower COP than electric boilers or heat pumps. And that's going to also be a lower COP, generally speaking, than a natural gas boiler as well. They're still going to produce those emissions on campus. So like your students will see that. Sometimes there is legislation that says you can't do that. It's also labor intensive. Somebody needs to get the fuel into the boiler. And depending on the type of fuel that you use, there might be a smell. So we mentioned manure as an option.
Neighbors might have concerns with that. Something to consider. Yep.
And then another big factor is that you need to have proximity to a place to get the fuel. If you're in the city, you might have a harder time getting, using the example of using manure again or something, you might have a harder time getting that than if you're out in the country, just as an example.
And you have to think about if you have to ship it, you're trucking it anyway, there's a carbon impact to that. And if it's from further away, even more carbon impact. Yep.
Yes. And it can be disruptive to the campus as well.
Definitely. Let's talk about gases.
Yes. So in this one, all you need to do is to get the fuel to your boiler. You generally don't need to make a lot of changes to that. It might mean you need a new burner, but that's not too hard to change in your boiler. We're still dealing with a lower COP. You're still doing combustion. The bigger thing that might be a problem, though, is that your fuel supply might be limited. It might be hard to get your hands on it. And then the biggest thing would be the cost. It might be such a high cost that it's not even a realistic option for you.
Great. All right, let's move on to hydrogen. I love this example, and you had a great example of a campus that you've worked with that's experimenting with it.
Yeah, so hydrogen is a fuel that when you burn it, it does not produce carbon, which is pretty cool, but it takes a lot of energy to produce it. And how green is that, or how much, what your carbon savings are will be dependent on how they produced that hydrogen. So they differentiate it by different colors. So green hydrogen would be your one that doesn't produce any kind of it's produced using windmills or water, just different options. And then blue hydrogen, it's going to be your next best, your purple, pink / red. Those are all the same thing. That's
funny that they can't make a decision there, but that's okay.
But it's one of the things that shows it's a new technology. They haven't quite decided on the nomenclature yet.
Yeah.
But that would be nuclear. So you're not dealing with carbon there, but you are dealing with, people's thoughts on nuclear power. And then gray / black hydrogen is you're using a fossil fuel to produce it. So like you can sort of imagine if you used coal to create the hydrogen, how, green really is the hydrogen in the end. Right. It might not be as good of a technology in that instance.
Yeah. So with that, let's look at some of those other pros and cons.
So once you have the hydrogen, you don't need to make large changes to your boilers. It's going to be something on part, like you're going to be putting in new burners. It's not going to be a really huge difference. And you can actually run a combination of natural gas and hydrogen, so you don't have to make that change overnight. Like if you don't have access to 100% of your need in hydrogen, you could use 5% hydrogen or 20%. And as it becomes more and more available to you, you can move more towards that. Or as your money becomes more available, or maybe the prices change. So it leaves you open to more options. However, as we kind of alluded to, and we talked about the different colors and how they haven't really decided on a nomenclature, this is a very new technology. You might not have access to it. It needs to be transported to your campus because it can't be produced on site. So, do you have a way to get that on site? And then the emission factors are not standardized. So it's a little bit hard to say what the carbon factors are for it.
Absolutely. And hydrogen, you needing to have a supplier nearby can be a big factor. And you were mentioning an Alberta client that Alberta as a city is wanting to become a hydrogen hub so that Alberta campus can leverage that. So that's something that you have to know as a master planner, like that this is going on and something that you have at your disposal.
Yes.
Awesome. All right, we've got about 5 minutes left. I want to be sure that we get to everybody's questions and answers, and feel free to keep putting them in the chat as you go. But let's talk a little bit now about that small modular reactor we alluded to earlier.
Yeah, so the SMR works by using fission, and it's kind of a cool little thing. It's going to be, they'll bring it to you in a little unit on a truck, and it's small. It can go through a lot of times it can go right through a doorway. And they can add modules to it. So if you want to start with one and add more later on, that's an option for you. But of course, the big thing that I'm sure everyone is thinking is the safety factor. And NIMBYism, when they say not in my backyard, because people get very nervous about hearing about nuclear reactors, and understandably so. Everybody's kind of picturing Chernobyl, but safety has improved a lot. But it's a matter of the appetite for the client has for this.
Absolutely. Thanks for that. And so it is an option, but safety will always be a factor that clients get hung up on frequently. And from my space as a communicator, that is a barrier, is like, how do we help neighbors come along of understanding that safety has improved a lot since the 80s when Chernobyl happened, but there's a lot of barriers in place because of that.
Yes.
Let's talk CHP.
So it's combined heat and power. And this could include cooling as well. So it's going to be a plant that produces electric power and heating at the same time. And you might even use a chiller off of the steam system as well. There's different ways that you can do that. You can do a back pressure turbine, condensing turbines, combustion turbines. And all those things are going to be kind of dependent on what the client, what kind of electric demands do they have? What kind of space do they have? How often do they want to overhaul it? That kind of thing.
Yeah, definitely. So the efficiency in combined heat power is the fact that there is this byproduct of that electric power generation. They're repurposing that.
Yeah. And so they will be doing some kind of combustion to operate this. Yeah. So it may be using natural gas, and then whether or not that's a green technology for them, a decarbonization technology for them, will be dependent on the electric grid and how that compares.
Awesome. Let's talk a couple pros and cons about CHP.
So a big pro is it gives you reliability for your electric power system. So if there's an outage in the grid, you don't have to deal with that. It does typically have an operating cost reduction, which is great because a lot of these technologies don't have that benefit. There are potentially carbon savings, which I mentioned. And then if you are very lucky, you have access to a clean fuel source, you maybe could do landfill gas, which is, we have a client who uses landfill gas to operate their CHP. And then as a result of that, they don't have carbon emissions from burning that. And so they're carbon neutral, even though they're doing a CHP operation, which is pretty cool.
That is really cool. I think from a bias standpoint, I think I had written off CHP as kind of old news because you can't do carbon free, but in that scenario, you absolutely can. So I think that's really great. Yeah, cool. Let's talk quickly about an electric boiler. I think we alluded to this earlier, but just talking through how this works and some of the pros and cons.
So it works using electric resistance to produce heat. It is 100% electric, so you do eliminate your scope 1 emissions. And then you have it's 100% efficient, so you have a COP of 1, which is that's a big improvement over a 0.8. 25% improvement is great. Yeah. But this will have a huge effect on your electric demand. And it might not be something that they can handle. And electric demand is going to be like the biggest factor for using an electric boiler. Especially because right now the peaks are usually going to happen in the summer. But then when you switch to an electric boiler, especially if you're in a cold climate, your electric demand is going to go way high in the winter months. And it might be more than the grid can handle. You could run into the utility company saying, okay, well, you're going to have to pay for it yourself, or they might say that it's not even something that's possible.
Yeah, that's a great point. All right, and let's wrap up with one last one, an exciting new one.
Yeah, so the industrial heat pump takes water from a low temperature heat source and it can produce steam, which is really cool. Just like the electric boiler, it's 100% electric, so it's going to get rid of your scope 1 emissions. But the COP is higher. You're now looking at a 1.5 or a 2 because you're moving heat rather than producing it. But you do need to have a suitable heat source. So you need access to something like a large body of water or geothermal wells. So it's not going to be for everybody. It does have a large footprint. And it's going to have a higher cost than some of the other options. But it is a leading edge technology. It has been in existence for years, so it's not, quite bleeding edge, as we say. But you're still going to be dealing with an evolving technology. It's getting better and better, and maybe in 10 years the technology is so much better that you kind of wish you'd bought it 10 years from now.
Awesome. Great. Well, now we have our cliffhanger. That's what we have time for today. And next time we'll get into more talking about the hot water technologies. But thank you, Kristin, for sharing all this awesome information and enlightening me for sure on some of my existing biases about specific technologies and informing me better. But with that, I'd love to open this up to the group for any Q&A that they might have for Kristin. We've had some questions go already. We've already covered Tracy's question about biofuels. And then Caroline had a question about any clients that are currently using the bleeding edge sort of technologies. And so Martha did respond in the chat to that, but Kristin, I wondered if you had any thoughts on that.
I don't think anybody would volunteer to be on the bleeding edge. But we always talk about oh gosh, you got Carol stuck in my head. The true geothermal well at
that's in New York. Cornell.
It's also a C.
Cornell.
Yes, thank you. So I was like, I just have a C stuck in my head.
Yeah, I was coming there with you. Yeah.
Yeah, Cornell is using a true geothermal well. They drilled down for for a mile to get to this thing, but they're getting 170 degree water out of that, which is pretty cool.
I'm glad you brought that one up. Personally, I was thinking, like, are they gonna cause like an earthquake from doing that? But they've been successful. So Martha's sharing a link about it in the chat. So we all have something to learn from that one for sure.
But that's an example of somebody who is willing to take a risk. So
yeah,
sometimes
and they did too. Cornell has a really interesting history of they were one of the first to leverage an actual body of water for their chilled water. They've been kind of on that leading edge since I think they enabled that in like the 80s or the 90s. It's been around a long time from what I understand. Because the field is constantly changing, it's impossible to be 100% on top of it. And I think that's another reason that why we're doing this series and why we want to engage more of RMF personnel in sustainability work is because it's impossible for any one person to be a 10. We need to have a lot of experts around the table that are putting in their 2 cents. And I guess that brings me to a question, Kristin, like, how do you keep track? You're so holistic in these plans. How do you kind of, do you have like a reference source, or how do you keep track of all of the things that are up in the air to be able to develop this plan for a client?
Um, it's kind of a hard question. Um, well, so we mentioned that first thing I do is look at their load profiles.
Yeah.
Sometimes something jumps out at me. It's like, oh, they have a great opportunity to do. For example, like when I showed the North Carolina one, I looked at that and said, they have so much simultaneous heating and cooling, and then they're warm year round. So for them, spoilers, but it's going to be a heat recovery chiller, and then an air source heat pump can pick up the remainder. And then chilled water, for the chilled water side, they can use a water cooled chiller. And that's actually a really, really efficient technology.
A super great point. The client was really upset about, not upset, but like they were disappointed by that. That particular project, our goal was to look at one specific area of campus and say, hey, what technologies from our decarb technologies list would you recommend for us to put in place for this great area? And they wanted us to say geo exchange. And when we did the math, geo exchange wasn't the right fit. And it took us a little while to get through the storytelling of why that was, because it wasn't just like it wasn't a really obvious thing. And the client here is like, oh, this nearby campus is doing geo exchange. Well, but they have hot water and you don't, so there's a lot different of an expense there. So I think that stuff is fascinating, that you think that you're going to know the answer when you get started, and the math tells you something different. And even Martha was surprised on that one, I would say. And she's done this a lot.
Yeah, we have to go ahead.
Sorry, we've got another question from Fabiha. What's the biggest challenge you often face with clients and their decarb goals? It's a good question.
Two big things come to mind. A huge one is funding. They might just not be able to do what even if they really, really want to do something, it might not be something they can do. But then the other thing, and you were kind of bringing this up, is a lot of times they come in with preconceived notions, and they want, particularly geo exchange comes up a lot, where they are absolutely sure that that's going to be the right thing for them. And that client that we mentioned in North Carolina, like they were so sure it was geo exchange. And when I told them that I don't think that's the right solution, they were so disappointed. And I went, but now you don't have to dig wells.
And you're saving all this money, and you're getting even better of a COP. Like, we should be partying. Like, that was a hard conversation to have. Yeah.
Yeah. And sometimes even when that is the news you're giving, that you're saying, I found you a great solution. Sometimes they just really want to do something else. And sometimes that can be a little bit disappointing on our side, because it's like, oh, I want them to do the thing that I think is the best option for them. But ultimately, like, they know what their goals are too. And they know what they need.
And we've had conversations internally of like, how do we really work to help the client understand, so that they don't just say, well, RMF didn't give us good advice, we're going to go seek out someone who will build this for us because we didn't take the time to learn why it's not the right choice. So we don't want to lose business to someone who's going to say, hey, other person that doesn't care that we want geo exchange, even though it's not the most efficient option, build it for us. So that's a really tricky one.
It is, yeah.
One thing I think I would add to this answer too is an issue with decarb goals being maybe a little more aggressive than what they can possibly hit. We have a lot of people with upcoming 2030 goals that are really hard to hit. And when I think about project management, a decarb project is a huge project. And there's kind of three things that affect a project. There's the cost. So are we willing to up the cost if we want this maybe faster, if we want to play with time, we want this by 2030? Well, that's going to affect cost and it's going to affect quality. So which of those things are you, client, willing to sacrifice if you want to speed up a timeline? And I think that's a really tricky thing when we're working with aggressive goals.
Yes.
What are your experiences with aggressive goals? Have you talked any clients off a ledge with that, or have you sort of just said, okay, well, we'll roll up our sleeves and figure it out?
I find that a lot of times at the beginning of a project, they'll come in and say, we are willing to spend whatever it takes,
And
then you
give
give
them a
them,
number.
yeah, until they see the number. And then a lot of times they start saying something different. But even if you have a lower budget, it doesn't mean you can't do something.
Yeah.
And I think that's like a really like important thing for people to understand, particularly like for the client to understand, is just because maybe you can't do, this really awesome technology that you thought was the right solution for you, doesn't mean that there isn't something you can do that makes a difference.
But Kristin, I want to thank you again for all of your great work on this. I want to credit Kristin she was part of the big idea of what eventually became Decarb Debrief, because she wanted to share this knowledge with the team. So we have at one point we had this Decarb 101 deck that we called it, that just had so much into it that we decided we needed to split it out. And so I want to thank Kristin and Andy and team for really wanting to share knowledge across RMF's greater team, because as we've talked about before, no one's a 10. So we have to be sure that everybody is contributing to the conversation. So with that, I want to thank everybody for joining us today. Thanks again, Kristin. And we'll see you back on August 15th, I believe, for part 2. Yes, that's Thursday, August 15th. You can sign up via Zoom. I'll also be sending emails. I'm sure you love my emails at this point, but they are supposed to be helpful reminders. So I hope everybody has a great rest of your day, and thanks again. Take care, everybody.